Okay, let's look at a simple vector addition equation similar to what you would be doing in lab. So here's the situation. I have a 100-gram mass hanging down, and then I have two spring scales pulling it up. And I want to find the force of this spring scale right here. Now what do I know? I made this stuff up. Okay. So I know that this is a 100-gram mass, and this spring is at an angle of 30 degrees, and I know the value of that force, T1, is going to be 0.6 newtons. So if this is in equilibrium, then the following has to be true. If this is in equilibrium, then I could say T1 plus T2 plus mg equals 0. So if something is in equilibrium, all of the forces have to add to 0. Now you might say, shouldn't that be negative because it's down? No, it shouldn't. Because these are our vector equations. The downness is contained in the vector part of it. But we'll make it negative in a little bit. Okay. So it's not easy dealing with a vector equation like that. It's easier to deal with the components. So let me write just the components in the x direction for these three forces. So I could write that as T1x plus T2x plus mgx equals 0. That's not a scalar equation. It's not a vector equation. It's a scalar equation now. So the first thing is to look at this gravitational force. Here it's pulling straight down in the y direction. So how much of it is pulling in the x direction? Well, in this case, it doesn't pull at all in the x direction. So this is 0. Now what about T1? Let's look at T1 all by itself. Here's T1. I know this is 6 newtons. I know this angle theta. I could break that into a vector in the x direction called T1x, and I could break that into a vector in the y direction, T1y. So now, using my definition of cosine of theta, this is theta 1. Theta 1 is it's adjacent over hypotenuse. So that's T1x over T1. So if I solve that for T1x, I get T1x equals T1 cosine theta. I could do the same thing for sine. Sine of theta 1 is equal to T opposite over hypotenuse, so that's T1y over T1. So T1y equals T1 sine theta 1. Okay, so now I can just put in my values here. Let's go ahead and do that. This is going to be 6, I left off the units, times cosine of 30. I think that's, you could get that in terms of the square root. I don't want to make mistakes. I'm doing it on my calculator. So, I'm sorry, this is 0.6 newtons. 0.6 newtons. 0.6 newtons. So 0.6 times cosine of 30 degrees. That's 0.52. Let's say 0.52. Round it. So this is going to be 0.52 newtons. If I do the same thing over here for the y, it's 0.6 times the sine of 30. Sine of 30 is half. So it's going to be, you can put it in your calculator too. So it's going to be 0.3 newtons. Okay, so let me write that up here. T1x equals 0.52 newtons. T1y equals 0.3 newtons. Now I can put that, I'm going to erase this. Now I can put that value for x in this equation and solve for T2x. So I get, if I subtract T1x from both sides, T2x is negative T1x. So T2x is negative 0.52 newtons. That's important. Now I can do the same thing for the y direction. So in the y direction, if I write the equivalent y component, you can see now I do have mg is all in the negative y direction. So I'm going to write this as T1y plus T2y minus mg equals 0. So now that's where that minus sign comes into play. Because now I'm not dealing with the vector. I have the y component. And gravity is just in the y direction. So I already know T1x. I can solve for T2x by adding mg to both sides, subtracting T1x from both sides. T2x equals mg minus T1x. So it's going to be, the mass is 100 grams, so that's equal to 0.1 kilogram. And then g is 9.8 newtons per kilogram. It's a constant. So I get 0.1 times 9.8 minus T1x. I'm sorry, this is T1y. What am I doing? A y. A y. T1y. Sorry. We're dealing with the y direction here, not the x. I caught my mistake, so it's okay. T1y of 0.3. So if I put this into the calculator, I get 0.68. So now I have both the x and the y component of T1, or T2. This is T2y. Now I want to find the magnitude. So if I look at this like this, here is T2 total. This is T2x, T2y. Since it's a right triangle, if I know the two sides, I can find the hypotenuse using the Pythagorean theorem. So T2 magnitude is going to be the square root of T2x squared plus T2y squared. So if I put that in, I get 3 squared plus 0.52 squared. It doesn't matter that it's negative. It's 0.52, yeah. I get 0.6. That's strange. Oh, 0.6. Let's continue. Okay. Now, if I solve for the angle now, I could do that the same way by saying here's theta 2, and then I could say, okay, tangent of theta 2 is going to be T2y over T2x, and I'm going to get, surprise, surprise, 30 degrees. Okay. I'm going to get 30 degrees because if you look, they have the same x component, they have the same y component. No, they don't have the same y component. That's from, no, they do. They're the same y component, so they have the same angle. Okay. Now, it was a simple problem, but still we can go through the steps of seeing how to solve these things, and hopefully that will help.